Hello children, today we will study about Unit 6 of Chemistry, that is Thermodynamics. Thermodynamics chapter you will also be studying in Physics. But let me tell you one thing beta, there is not much difference between Thermodynamics of Chemistry and Thermodynamics of Physics. So please listen carefully so you won't get confused between the concepts of thermo of physics and concepts of thermo of chemistry. So first of all, what do we mean by thermodynamics term? As this thermo words related with heat, dynamics, motion. So simply we can say in this unit we will be studying about flow of heat, different forms of energy like heat, work, entropy, Gibbs free energy, enthalpy. So many different forms of energy are there. We will be studying about all these forms in this unit. Got it? So before studying this unit in detail, first we talk about some basic terms which we will be using in this unit. Like the first term is system, then surrounding. The next one is universe. Now, what do we mean by system? So, system means anything which is under discussion. The part of universe we discuss about. Right? Means anything which we are discussing, which we are studying, which we are talking about is termed as system. Doesn't mean that this word we will be using only in chemistry or in thermodynamics. Like at this moment, I'm talking about thermodynamics. So for me, now thermodynamics is system. For example, if you're talking about any movie, then that movie becomes system for you. Understood children? What do we mean by system? Means anything which we are studying, which we are talking about, which we are discussing under consideration, that becomes a system. Then coming to surrounding, remaining part of universe excluding system. Right? Remaining part of universe excluding system is termed as surrounding. Simple term. Now coming to universe, system plus surrounding becomes universe. So system and surrounding collectively they are termed as universe. So these are the three basic terms which we talked about. Yes, now just I have taken this example to further explain about system, surrounding, universe and how they are separated from each other. Like in this figure, I'm having a liquid. I want to talk about the properties of this liquid. So at this moment, this liquid becomes system for me. And this remaining part becomes surrounding and collectively I'm calling them universe. Right? Now system and surrounding, they are separated by a boundary. There is a boundary between system and surrounding. This boundary can be real or can be imaginary. The boundary between system can be real or it can be imaginary. Like here, this is system and this part is surrounding. So there is a real boundary. You can say this, there is a real boundary between system and surrounding. But at this point, like this is the surface of this liquid, so and this part is surrounding. So here there is no visible boundary between system and surrounding. So this is the meaning by real boundary and by imaginary boundary between system and surrounding. Now let us discuss about types of system. There are three types of system: open, closed and isolated. First we talk about open system. As the name is suggesting, open system means this will be exchanging both energy and matter with surrounding. It will exchange both energy and matter with surrounding. Exchange of both takes place. Closed system will only exchange energy. Exchange of energy takes place, but no exchange of matter. It cannot exchange matter with surrounding. Isolated system, it neither exchanges energy nor matter. Cannot exchange both with surrounding. This was the definition of these three types of systems. Now take the example to further clarify their meaning. For example, I am taking hot water in a container which is open. I am not closing this container. Now this becomes an open system. Why open system? Because this container, the hot water which is filled here, will be exchanging its heat with surrounding, as well as water vapors are moving out. So in the form of water vapors, exchange of matter is taking place, as well as after some time it becomes cool, means it is exchanging its heat with the surrounding. So in this way this becomes an open system. In second case, if I close this beaker, cover it with a lid, taken hot water in the beaker and the beaker is covered. Now vapors cannot move out. It means it cannot exchange matter with the surrounding. But clearly it is exchanging its energy, heat is moving out. Because we know heat always flow from hot end to cold end. So slowly it becomes cool. It means exchange of heat is taking place. And we know heat is a form of energy. Right? So this becomes a closed system. Now talk about isolated system. If I place this hot water into an insulated container like thermos flask, the container has insulating walls. Now it cannot exchange heat with the surrounding, as well as no exchange of matter. So it becomes a isolated system. Next topic is the state of the system and state functions or state variables. The meaning by state of system means the physical existence of any system under some specific conditions. So the state of system is always defined in terms of certain variables. So what do we mean by these state variables? State variables are some measurable properties which defines a system. Like if I'm having a gas cylinder fitted with a piston, a gas was filled in this cylinder. So how do I define this gas? In terms of its pressure, volume, temperature, number of moles. So all these becomes state variables. Like if I'm saying the gas is present at 1 atmospheric pressure, volume of gas is 3 liter, temperature 300 Kelvin. In this way, all these are state variables for this particular gas. So the condition of a system is defined in terms of certain variables. They are termed as state variables or state function. So certain variables are pressure, volume, temperature, number of mole, internal energy, then enthalpy, entropy, Gibbs free energy. Don't worry, we will discuss all these terms in detail. But yes, you know well about these terms at least. Right? So this is the meaning by state variables or state function. There is one more way to define state function, that state function is those properties whose value depends only on initial and final state. What do we mean by state function? The properties whose value only depends on initial and final state, does not depend on the path. Means from where you started and from where you reached. That's it. This matter. It doesn't matter how that change is taking place. What process you are following, what path you are following, independent on that. Clear? This is the meaning by state function. So it means pressure, volume, temperature, all these are state functions. The second property is path function. As the name is suggesting, properties whose value depends on the process or the path followed by the system. They are termed as path function, like work, heat. These are certain examples of path functions. Next topic is types of thermodynamic process. There are 4 types of thermodynamic process. The first one is isothermal process. Check the meaning of this term. Iso means same. There are many terms we discussed like isobar, isotopes. Remember these terms? Isotones, no? In atomic structure we talked about all these terms. So the meaning of iso is same and the thermal word is related with temperature. So the definition is very much clear. The process taking place at constant temperature. The process taking place at constant temperature is termed as isothermal. Or we can say during complete process, delta T remains constant. No change in delta. Delta means change. Change of temperature is 0. No change in temperature taking place. Like if you remember, in states of matter unit, we talked about Boyle's law. The condition of Boyle's law is isothermal condition. There, we discussed the relationship between pressure and volume at constant temperature condition. So we call that condition as isothermal condition. Right? So now the next type of thermodynamic process is isobaric process. Again, the meaning of iso is same and bar is the unit of pressure. So now the definition is clear, I think, to you. The process taking place at constant pressure. Or we can say delta P is 0 for this kind of process. And children, remember one thing, most of the chemical reactions are carried out at constant pressure condition. Correct? So now the third one is isochoric. Volume remains constant or throughout the process, no change in volume, delta V is 0. So the definition is very simple. The process carried out under constant volume condition is termed as isochoric process. Then the fourth type of thermodynamic process is adiabatic process. The process taking place when heat remains constant throughout the process, or we can say change of heat is 0. No change of heat taking place during the complete process. So these are the 4 different kinds of thermodynamic process. Okay. all these four kinds of thermodynamic process further categorized into two categories, that is reversible and irreversible process. Every process, whether it is isothermal, isochoric, isobaric, adiabatic, can be divided into two categories, reversible adiabatic, irreversible adiabatic. Yeah. So now what is the meaning by reversible and irreversible process? I think everyone knows the meaning of reversible. Takes place in both the directions, forward as well as backward. But irreversible only in one direction, in forward direction, right? This is the basic difference between these two terms, reversible and irreversible. But let me explain it further. Reversible process is the process which takes place infinitely slowly, or should I say rapidly? Just try to think about this. But should I say this process, reversible, takes place very, very slowly, extremely slow rate, or rapidly? But it should be. Can't guess? Children, just think, if you want to reverse something, then you should move at a very, very slow rate, so that at every step there is a chance to come back. At every step, at every moment, you are having a chance to come back. But if a process taking place at once, suddenly something is happening, cannot reverse it. No chance. Because in between the process, we are not getting any chance to reverse it. So we can say the reversible process is the one taking place at a very, very slow rate, infinitely slowly, so that at every moment we have a chance to reverse it. But it's a rapid process, fast process. So extremely slow, and this is very fast. So takes place at once. We cannot reverse it. Then in this case, there is an equilibrium at every stage. But here, should we say equilibrium or no? Both are there, beta. Means initially there is an equilibrium, finally there will be equilibrium. But in between, no equilibrium. That's why we cannot reverse this process. Right? And ideally, this situation is an ideal situation, but this is a real situation. Practically, that is possible. This is not possible, that every step we are taking place at extremely slow rate. So the process can never ever reaches to completion. But this reaches to completion. So this one is a ideal situation. And this one is a practical situation. Yes, children, understood? Now, this was all about different types of thermodynamic processes.